Okay, let's continue from where we left off last time. We'll still talk about pointers for a while because pointers is probably the most difficult thing in the C programming language. It's also useful for C++, and it's used very extensively, so we'll have to understand pointers very well before we do other things with the language. So let's go back to our program swap and let's do a refresh. So the program is very simple. What we did is we declared and defined two variables, a and b, which were integers, and we assigned the value 10 to a and the value 20 to b. And then we printed those two variables. So as a result of this printf over here, we'll get the a equals to 10 and b equals to 20. That's what we expect. And now we do a swap of those two variables. In order to swap the values in two variables, we need a helper variable. So we defined a temp. We defined the integer variable called temp over here. Because what happens if we assign b to a without a temp? We will lose the value of a immediately. So we first have to store one of them in temp, which we're doing here. So we're putting a into temp. So temp will receive the value 10 because a is equal to 10. And then we assign the value of b to a. So 20 will be assigned to a, and now a will be equal 20. And that's why we had the original a inside temp, so we don't lose the original value. And in the last command we say b equals to temp. So temp was 10 because temp took the original a, and then a took the b, which was 20. And after b equals temp, we'll have a, which is equal to 20, and b is equal to 10, right? If you just do a dry run on this, you put a small table of variables, you'll see how the variable values are switched, and the 20 will be assigned to the a and the 10 will be assigned to the b. So now we print again a and b, and when we print it again, it will tell us that the value of a is now 20 and not 10, and the value of b is now 10 and not 20. So let's see how it works with running the program. Let's run the program. Okay, let's run swap. Let's see what we get. Okay, so the value of a is 10 and the value of b is 20, which is the first print, which is correct. And then the value of a is 20 and the value of b is 10. So it swapped and it put the 20 that was in the b in the a, and the 10 that was in the a it put in the b. Everything as we expected. And now let's do something new. Now let's define a function that will swap the values. Instead of doing it in the program, in the main function, which is our program, let's define a new function, and we'll call this new function swap, and we'll give it two integers. So now I am declaring or writing the prototype of the function, right? We do that before the main, we write the prototype or the declaration, and now we need to write the function itself, the definition. So the definition of the function will come after the end of the main, right? This is the end of the main. And we'll define void swap function, and here we'll have to define variables. Let's call it x and y. Those are the parameters. And here we'll define integer temp equals to x and x equals to y, assigning y to x, and then y gets temp and ending the swap function. So this function does what we did in the main program, which was here. So we'll put all this inside the comment, because now we're doing it in the function. And now we have to call the function, of course, and we call the function by mentioning its name and giving it the arguments, right? I don't know if I mentioned to you, but when we call the function, we call it with what we call arguments. When we write the function, we write it with the parameters. The arguments are the actual values that we want to use the function with. So here I do swap of a, comma, b, because those are the actual values that I want to swap, right? They are here. Swap a and b, so I call swap with the arguments a and b, and the function swap has the parameters x and y, so x will get the value of a and y will get the value of b, and then it will do the swap and everything is hunky-dory. We'll do the swap for us, and then we'll print a and b, and we expect to see the same thing. First it'll print the first one before the swap, a is 10 and b is 20, and the second print after the swap, so it should give us a as 20 and b as 10. So let's see if that works. Compile was successful. So let's go to the videotape and let's increase it. And let's run the program again. Remember, now the program works with the function. Before it worked inside main. Everything was, the swap was inside the main. And look what I get. The value of A is 10 and the value of B is 20. That's okay. And then I get the value of A is 10 again and the value of B is 20 again. So it didn't do the swap. Even though I called the swap function, it looks like it didn't execute the swap. So now we're getting to the core of what I wanted to show you today. And what I actually wanted to tell you is when we call a function, like here, with arguments a and b, the function copies those arguments and it doesn't touch the actual ones that we give it, but it makes a copy of them and it works on a separate copy. So x and y, even though they get the value of a and b respectively, inside the function they do not change the values of a and b in main. That's the way C works. It just makes a copy of the arguments, and inside the function it cannot impact the variables that were defined in the calling program, which is main. So how do we do that? We still want to use a function in order to change or swap the values. So the way to do that is to define them as pointers. And now we'll go up to the prototype. We'll change the prototype. So the swap will not get 2 integers, but the swap will get 2 pointers to integers. And since we already mentioned what pointers are, we'll go over this again. Now swap gets a pointer, because the pointer has a notation of asterisk, right? So int asterisk means a pointer to an integer, and the second variable is another pointer to integer. Now, if I call the function with pointers, then I have to provide the address of a and b. Not a and b variables, but we know how to take the address with the address operator, which is ampersand. So now, since I defined the 2 parameters of swap as pointers to integer, I have to give the addresses of a and b instead of a and b themselves, right? So pointers receive address because a pointer is an address of a variable. And we also have to change the definition of swap itself. So I already prepared the version that will be the one with pointers. So we'll put this one in comment, and we'll take out of comment the version that I prepared before, and we'll just go over it and see what it's doing. So I wrote a version of the swap function this way. The swap receives 2 parameters that are pointers to integers. One of them is called x, so int asterisk x. X is a pointer to an integer, and int asterisk y. Y is a pointer to an integer. And inside the function, I define temp again, and in order to take the value of x, remember I said that in order to take the value that the pointer points to, we use the asterisk operator, and that gives us the value that sits inside what x is pointing to, because x is a pointer. So the value of x goes into temp, and here I put the value of y into the value of x, right? Asterisk says the value of that pointer. X and y are pointers to integer. And then the last command is to put temp into the value of y. So this is the swapping mechanism like we used before without pointers. Now we use it with pointers. So now let's see if that works. And now we also called this new swap, we called with the addresses. So we changed 3 things. First thing we changed was the declaration of swap, to declare it with 2 pointers. Second thing we changed was to call swap with the addresses of the variables instead of the variables a and b. And the third thing we changed was the swap function itself, the definition of swap. We made it with 2 pointers to integer, so we needed to do the swapping with pointer notations, and we already discussed the pointer notations where asterisk name of the pointer gives the value. So now all we have to do is compile and run and see what we get. Okay, compiled successfully. Now let's go to the videotape again, and let's run this version. So swap, and what did we get this time? You see, the value of a is 10 and the value of b is 20 as before, the original, and then the value of a is 20 and the value of b is 10. So he did the swap this time. And the reason he did the swap is because we gave the function, we gave the addresses of a and b. When we give the addresses of a and b, the function swap changes the values in those addresses, and those addresses remain a and b. So even when we come back from the function swap switched actually the value of what we had in the address of A with a value that we had in the address of B. So now, since we print A and B here, we got the different values. Okay, I hope you understood this. If not, you can watch it again. But basically, this is the first thing that's really useful with pointers, and the next lesson about pointers will talk about the similarities of pointers to character arrays, and we'll probably do at least 4 or 5 lessons on how pointers are similar and also different from character arrays, what we can do with them, and the flexibility that we get when we define pointers as arrays, and how C handles it. It's a little bit tricky, but we'll have several lessons, we'll go over it, but this one is also important. I hope you understand the concept of pointers and addresses in memory, because as I said, if you understand that, then everything that we'll learn from now on with C and C++ will be clear, and you can understand more stuff and do more stuff, and we'll do some more fun programs after that. So this is it for now, and let me know as usual if you have any questions.